Hey guys, I am Santosh and you are watching YouTube channel FANUC PLC and CNC tutorials. In this video, I am going to show you how to write your own PLC ladder for coolant motor. So this is a coolant motor, coolant pump motor. This is used in CNC machines. Okay, this coolant pump motor will provide the coolant oil to machine. Okay, during cutting operation. Okay, so let's start. In this video, I will show you uh, wiring of coolant motor, control circuit, power circuit, and how to write your own ladder program for coolant motor. Okay, and what are all electrical components we need for coolant motor circuit. Hmm. So before going to start this video, subscribe our channel. Okay, our channel name is FANUC PLC and CNC tutorials. So let's start. So basically, coolant motor will provide the coolant oil to machine. Okay, during machine cutting operation or machining operation. Okay, we can operate coolant in two methods. One is auto or MDI using M code. We provide the we command the M code M8 coolant on and M code M9 coolant off. Okay, and for using button also we can switch on and off the coolant motor. The button is available on operator panel. Okay, using on off button, coolant on off button. Okay, so now here the circuit. So basically in circuit we need to switch on this coolant motor. Okay, so for this I am using here one contactor K1. Okay, this is a contactor, normally open contacts, and the coil of this K1 contactor is here, K1. So whenever this K1 contactor is on, this contactor coil is on, that time this normally open contact become close, and this three-phase supply 450 volt AC supply will go like from this to and here motor, and motor will on switch on. And here you can see this is a Q1 is a MPCB, okay, for short circuit protection. Okay, and this is the R1 is a overload relay for overcurrent protection. Okay, so as soon as this K1 contactor on here, this coil is on, this close, these three contacts will close, and the input supply will go from input to motor, and motor will on. And again when this K1 contactor is off, okay, this contact become open, and that time supply will not go this side, this main supply, and motor will stop. Like this circuit will work. And now the question is, when this contactor K1 should on, when we have to switch on this. Basically this contactor is switch on by 24 DC and 0 volt. Here you can see I have given a 24 DC common supply. Okay, and this side 0 volt is coming here. How? This 0 volt, this is a relay, control relay. So this 0 volt will come like this, like this way, and this 0 volt is available here. Only when this relay should on, you must switch on this relay, control relay, CR, control relay. Okay, so when this relay is on, when from FANUC Ayog PLC Y0.0 address is on in ladder, PLC ladder program, that time this FANUC, this is a FANUC Ayog card. So when Y0.0 is on in ladder program, this from this 24 volt will come outside, and this coil is on. See, for this coil 24 volt is given here, and 0 volt is common given here, and this coil is on. So this coil is on only when in your ladder program here, when this in ladder program Y0.0 is output is on, that time this 24 volt will come here, and this coil is on, and this is normally open become close. Okay, this is a common point, normally open O1, this is close, and this 0 volt will go, and this coil is on here. Like this circuit will work. This is a control circuit. Okay, and this is a power circuit. And here you can see this is a push button wiring. Okay, suppose if I want to switch on coolant using button, coolant on and coolant off. Okay, coolant on button, coolant off button. So this two input, this is a FANUC IO card, input is connected here. Okay, and this is common 24 DC like this. So let me show you the components. See, this is the MPCB, this one, or short circuit protection. And next one, this is the contactor, this K1 contactor, and this is coil, this one, and this is the overload relay. this one. This overload relay we are using here because we need to protect this circuit from overcurrent. Suppose if overcurrent comes to motor in circuit, so it will protect. Okay. And then relay, 24 DC relay, control relay, this one, CR, this one. Okay. And next, this is a relay model. Actually, this one. This relay is available on this relay model board. Okay, relay channel. And this is push button. Okay. Actually, we are using two push buttons for on and off. For on button, this normally open is there. And for off button, normally close is there. Okay, this one we are using. Here, this one. Normally open and normally close. And this is SMPS. It will give 24 DC and 0. So we are using here and here all the 0, this 24 common supply we are using from SMPS. Okay. And also we are giving a 24 and 0 to FANUC IO card also. And this is FANUC IO card we are using here. See this one IO card output and this is input connections. So this is the circuit. Now I will show you how to develop the ladder program for this circuit coolant motor. Okay, basically I told you we will switch on the coolant motor using M code in auto MDI mode or using button on off button. So let me start here. See here I have written a ladder. This ladder is for a coolant on automatic mode and this is for coolant on using button. Okay, so here you can see this RQ100.0. I have used one bit, address bit. So this is on when I command M8 M code. So whenever I call M code M8 in auto or MDI mode, whenever I call M code M8, that time this output is on and this is latched here, hold. Okay. And using this output address, I will come here, same address R200.0. I will switch on coolant motor output. And whenever I call again M9 coolant off, then this is off, and this is off, motor is off. Okay, like that way. So before you have to switch on coolant in auto or MDI mode, some conditions you have to consider. Before you switch on coolant, you must switch on the spindle. See here, spindle on bit I have created here. So this R200.0, let me show you. See R200.0. So whenever spindle on in FANUC, forward or reverse, this output is on here. So only if spindle is on, then I will switch on the coolant. Otherwise, I will not. Okay. And emergency release condition you must is there. And coolant off button is not pressed because coolant off button, no. This is normally close contact, right? This coolant off button normally close contact. So the status of this input bit is always 1. So before it is only, previous only it is green. Beginning only it is green. Okay. So this is green, this is green, this is green. And make sure you don't give M code M0 or cycle hold button. Don't press. Okay. Don't press reset button. So then all conditions okay means this is on. And here this is on, this is on. So this is auto MDI ladder. Similarly, this is manual ladder. So when I press coolant on button, I will switch on one more R address here, R200.1. I will hold this. If it is on below, I will switch on again coolant. Means coolant on is switch on using auto bit or manual bit, both, anyone. Okay. So when I switch on coolant on button, this is output is on, it is hold. This is latched and till when I press coolant off button. Okay. Once I press coolant off button, this is off, this is off, and this is off. This off means coolant will off, like that. And here also in button also, when you press button to switch on coolant motor, here also you can take same condition. Spindle must be on. Okay. Like this way. And here in auto MDI, suppose imagine you have called coolant M code M8. Okay. Now coolant is on. In between, if you command M0, program stop M code, coolant will stop. Same time, if you press cycle hold button, coolant is off, like that. So these conditions we have taken here. Okay. So like this, you have to develop your own coolant motor ladder. So this is a circuit. And this is all components we have used here, all. And here these are the component list, whatever I have shown, in slide, that one is list. Okay, I hope you understood this video. Okay, if you have any doubt, you can comment the below video. Okay, and don't forget to subscribe our channel. Okay, and also share our videos with your friends. Okay, thank you for watching with this video. See you in next video. Bye.